So I think we are back and let's just start programming from where we left off. So I was doing the CS uh, binary tree programming assignment, and one issue that I was facing. Oh, so I'm going to keep the music a little bit lower so that uh, my voice can be recorded. I think that it is working correctly. Yeah. It's not picking, the microphone is not picking up the background speaker noise, and I have kept it at a lower volume so that at least some background noises, not background noise, some background music might be there so that we can have a soothing experience. And with that, let's see how much we did in the last session. And we were able to create, and most of the thing that we were organizing was mainly with regards to the utils.h and utils.c, and hopefully we have, if I just go to utils.c, we have made most of the stuff that we need. Now I am going to open up one more terminal here, or not here per se. Let's just open it on the side, just so that I can have two working spaces. So with that, let's go to, and one more thing, I was having this issue that, not an issue, but I was noticing that my voice was not that clear because probably of my accent. And what happens during speaking is that you do need to be a little bit more clear when you are recording it than when you are in person, and that kind of pushing out that voice throat, like probably the throat of the voice was not that accurate, or maybe you can say was not that correct. So yeah, I do apologize for the first session where I might be lacking a little bit of energy, and I know it's night, and let's try and make it better. So this is recording. Hopefully I'm not having any issues. So let's start with binary search tree. As you can see, what we need. So no, not binary search. I think we should do the normal binary tree because there's a programming problem set 1. So I am seeing that I need this display function in order non-recursive, then post order non-recursive. I need to find get height. Okay, I need a lot of these functions basically. And like let's create a template first. Oh, by the way, this main function, I was thinking, okay, we need to make the menus right, and making the menus will be hectic as hell, but let's see, because we need to complete the assignment. So let's go back, and first let's make the binary tree.h, because we are going to be first making the header files. So of course, let's just have will it? Okay, it did work, but somehow it, whatever. So I'm still like trying to understand how the nvim this lsp for C is working. If I do this, then it gives me the correct format, but whatever. So mine is binary. What's the name below? It's binary tree. As you can see, I named it binary tree.h. So the name here should be binary tree. Instead of dot, we are going to have underscore. And with that, let's just do the define. And of course, I have to make it the same. With that, this block ends. So let me clean this up. And yeah, inside this we are going to be putting up our code. Hey, by the way, did I just a second, let me go back and go to utils.h. So as you can see, yeah, endif is there. I just wanted to check if that's all right. Now let's go to main, and I'm just going to keep the main open so that we do need to make the functions for it, right? So how much I've done? I've made the main menu and all this. So hey, let's create the, I think we can create the main menu first. And yeah, so let's create the main menu now. Okay, then one more thing I would like to say here is basically the formatting. So sometimes people do have this formatting of, like, you can have, what do you call this, main menu, nothing menu, the main function before everything else, before you declare the other, not declare, basically define the other functions. So depends which kind of architecture you are following, not architecture but programming paradigms you are following. But I do tend to sometimes prefer the main to be at the first, and sometimes I do prefer the main to be at the last. It kind of changes, but there are programmers who basically have this one thing. Okay, first, should I make the main menu first or the okay, we are making the practice set one, right? So let's just do away with the practice set menu so that we can just organize our thoughts, like basically what functions do we need for this binary tree. So we are going to basically write print f, and it will be basically backslash n. Let's just design it a simple bit, like practice set 01, which is basically what, binary tree operations. What is the name? Practice problems, binary tree practice problems. And I give a space there, so 1 2 3. Makes sense? Well, these are just basically printf statements. Doesn't matter. First question. Write a program to implement the insertion operation in a binary tree. Note that, okay, basically you are going to do insertion operation, right? So we are basically going to be making the, like, inserting the node one by one. So insertion done manually. Should I just write problem 1? Maybe, depends. Now let's do another printf. And okay, remember we do want to try and basically have this in an order, like basically you see that this, okay, this 1 and 2, basically they are down, like, but not down exactly at the same place, so that we can have the code looking better. Well, I can't explain this. Basically we're just formatting it, that's it. Now what's the second problem? I just make a display function. It's just that in the screen properly. Okay, basically I just need a display function. So display tree properly, something like that. And let's just have it called problem 02. And okay, printf tree, probably it was in order something, it was in order non-recursive, so in order traversal we are doing the non-recursive one, so non-recursive, and that will be your problem number 3. What is, yeah, no, problem number 3. Let's just have it like that. Then printf. Let's go for the 4th one. It was, if it's in order, then probably the next one was post order. Let me just check it once. Wait, I said, yeah, it is post order. Okay, and because I'm just typing it here, let me just have it. Yeah, now it seems more clear. I feel like it's way more clearer. So post order traversal. Again, this is non-recursive. Recursive. This is problem 04. Oh, there are how many problems if I remember? 12? I don't know, 18, so I have to go and solve. I have to write till 18. Okay. And you know how we need to make the main function as well. So I'm just going to keep the prototyping here a bit. Now let's create void. What was it? Display main menu, right? Display main menu. So print f. So we can actually just have some more formatting. Let's make it equal to 1 2 3 4. How many did I give? Probably 6, whatever. So this is main menu 1 2 3 4 5 6 probably. Print. So basically we have to write a bunch of printf statements. So first would be, I want to have this, like basically we are going to create a random tree. Wait, I remember Somo was telling me there is a difference in the meaning of random tree from mathematics and computer science. Random tree is a computer science. Random tree is yeah, it's formed by a stochastic process. Okay. Probably we are going to make a uniform spanning tree. No, we are not going to. With various random distribution, including trees formed by random insertion orders. Maybe a binary tree. That's actually an interesting thing. I did not know that there were different types of like random. Basically, it's not like, it makes sense because you have an underlying probability distribution besides selecting those random numbers. So your random variable is coming from a probability distribution, and that is defining how the tree is basically getting its values. So if that's the case, this will be a uniform random tree, and I shall be making it because I want to have this function. I don't know how I am going to do it. Probably I have to read up a few docs while making it, but well, that's the fun of doing it, right? So generate tree from basically user input. Basically we are going to use the same function, manual insertion. So manual insertion, because I want this to be in the main menu, so that once the user enters all the nodes, we are going to apply in order, post order, get the height, whatever be the order. Not whatever be the order, whatever like be the question be asking for. And I guess I forgot to bring a water bottle just so that I can just drink some water while I'm narrating all this. Now Also, I'm going to use where is it? Yeah. So if I just go to this one, as you can see, our professor actually did this hard coding. So I also want to have a hard coded tree. So for testing basically. So what do you call this? Use the hard coded example tree. Next we are 1 2 3, then this 4 we are going to make basically the display whatever the trees are, current trees. I'm going to make different ways, like maybe there were some questions, right? If I remember correctly, there were questions like where we need 2 trees and probably do comparing something like that. Yeah. If 2 binary trees are passed, so basically we do need 2 trees. So this particular function will show all the current trees, and based on that we are going to do, basically we are going to have 2 trees, maybe 3 trees. Let's see, let's create first. We are just prototyping, not prototyping, currently thinking about how we are going to approach this. So next with the, basically just go to practice set 1, practice set 01, then 6th will be practice set 02. Next, basically we just do an exit at this point. I probably have no more things to do, so exit, and yeah, we are done. We're done with the main menu. We are still not done with this what do you call this? Oh, I did something wrong there. I still need to make all the print statements for this. Post order के बाद क्या है? Let's make it. How much time will it take? 10 minutes. Find max, right? So find max means basically returns the maximum number stored in a binary tree. Okay. So find the maximum what do you call this? Maximum value from the binary tree. Okay, by the way, when I upload this, because you know this function, making these functions is quite trivial, you basically don't need to spend your mind behind doing all this, so you guys are totally free to just skip it. Okay, like you can skip it and go to the part where I'm solving this instead of just writing it. So it exists. I remember in class I was seeing this function again and again being called, basically if the value exists or not, and this is going to be very crucial, that's going to be used again and again inside our functions. So if the value exists, now next is, oh wait, it was, did I mess up the numbering? No, I did not. 7 is get the tree height. 7 is get the tree height. Eight is get the tree level. Not tree level. Level means basically I need to have the node, right? Yeah, I of course need to have the node level of D in a binary tree. So basically D means this is the node, right? Data. Okay, wait. Write a function such that it gets the level. Okay, I forgot the definition between difference between a level and height. Difference between the level and height of the binary tree. Distance of a node from the root, while height refers to the distance from a node to its deepest leaf. Oh, so do I have a diagram? Okay. So 0, 1, 2, 3, 4. That means this is the depth 4 and the height is 4. Let me just go to the definition once. Height of a tree is the number of edges we travel between the root node and node, probably the given node, while traveling in top to down manner. Okay. Height of a node is 0. Height of root node is 0, of course. So level of a binary tree start from root node with value 0 or 1. Yeah, so I wanted this depth of a tree and height of a tree. The depth of a node is the number of edges from the node basically. Okay, so if I just go to this function, we are getting height and level. So depth means level, I think, from the node. Okay, to the tree's root node. Okay, and thus the level means the same. Where's the level of the level? What does height mean? Height of its root node or equivalently the depth of its deepest. So basically from here to here is the height. From here till the node which contains no child. Okay, makes sense. By the way, hopefully YouTube won't ban me because I'm going to have a lot of phrases like which which are basically computer science terminology, but might be controversial. Wait, so let's just see. Oh, by the way, recording and everything. Okay, good. So the height of a tree would be the height of a, yeah, so that's there. This diagram makes a lot of sense. So here the depth is 0 but the height is 3. So 3 means 1, 2 and then 3. So height is the distance between the root node and the, let's say, leaf, and depth means given a node, what is the distance between that given node and the root node, and depth is basically what we call as level here. Okay, now it makes a little bit more sense to me, because now get the given nodes depth / level. So I shall be using the same terminology that professor has used in the assignment, that is basically level, but I'm just keeping it written like this so that I can refer to it later. Now, what's the next thing that I need to do? Level order. Oh, level order traversal. Okay. So level order traversal. What? Okay, that's a very weird thing. Okay, so let me just do some self branding if that is allowed. I don't know. So, oh, I might be saying this phrase. I don't know again a lot, because that's one of my, what do you call this, speaking styles, and basically I can't do anything about there. So I have had done the AVL tree implementation way back. It was in large, it was sometime I updated it a bit with the Python one or something. If I just go to the you see the comments. I think it's in the insights. So comments, crunching the latest data for you, just for you. Okay. Yeah, of course there are no comments in this here, man. I don't know how to see it. Okay. So here I implemented the AVL tree logic written in C as well as in Python. So this is there. See the difference. Just like in C it took about let's say 250 lines. Okay. In Python it only took about 180. Okay, that's not like too much of a difference. It's weird, but basically when you go to that data structures, it's more about the writing the logic and not about reducing the number of lines that you need. So I have this sorry, basically I'm feeling a little bit sleepy, but I remember I have that level order traversal, but basically I'm going to implement it again, so don't worry. Level order, then what do we have? Zigzag order. Okay. Zigzag order reversal. Next, what do we have? Get the leaf count. Okay. Get the leaf count, then I think it was get full node count. Means what is this? Oh, complete nodes are full node. Okay. Only one child, half node. Okay, so leaf, then full, then half. Okay. Get the leaf node counts. Range. Get full, right? Full node counts. Get the half node counts. When it is done, we need to check if the two trees are identical or not. So print check the next one was probably for the mirror. Yeah. Check if the trees are enantiomers. If you are in chemistry, you know what it is. And if you are not, just Google it. Probably everyone in IISER knows what enantiomers are. Huh. What do we have next? Print ancestors. Oh, okay. I actually don't know exactly how to do that at this point. Probably if I just get I think if is exist works, basically I can modify the is exist function and then I do it. Okay, let's see. Print the ancestors. Okay, next. Oh, breath of so what do you call this? Max width, right? Usually, so get I'm giving semicolons away. Finally, we are at the 18th printf statement. Oh, okay. Basically, same as the first one, but a lot of the conditions are there. Build a complete binary tree user input. Now, this is probably how much I'm going to do this part. Oh, wait, I do need this to be open so that I can make all the functions for it. I still need to make, okay, if, by the way, I'm going to require one more root for it because I need two trees basically for this identical and this enantiomer stuff. Should I make the main now or should I work on the binary trees? It's a dilemma. Now, because I started working here, it's just this. And let's increase the font a bit. Now, so we need to have a lot of functions, but first, what do we need? The basically. Let's just have something like problem. So something like this, and let me yank it, paste, paste, paste. I'm going to just create a bunch of lines first because I know I'm going to require a lot of lines. Paste, 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 paste. Okay, I don't know how many I did, but probably should be enough for right now. So 01. Basically, I need first function would be insertion done manually. So let's just name it insert load manual. Now, what should be the return type? Basically, let's just have it BT node. I think that should be good enough. Okay, now what do I need? BT node. Basically, I need first I need the main node that I'm in Snow. What do I need actually? If I just go back to the question, the number to be inserted, so that's the data, then parent, whether right or okay, so direction can be given in left and right, so probably in a character, and I need the root node. I need the reference of the root. Should I use double star? Oh, I forget this again and again. So let's just go back to here. This is probably some stack for what? What happened to that insert? There was some function, right? I think it was some double star, right? Okay. There was something. Where is that code? Are the codes here? No, this is just the Kripa sir's notes and boots. Where are those? Uh, don't tell me sir actually deleted it later. Or he was actually editing it in class, if I remember. So, nah, it's not there. It's very difficult to find this kind of codes online. So, binary tree in C node insertion. So, level order. Oh, yeah, that's true. In what order does the user actually insert it? Ah, no thought. Like, does the question ask for it? Oh, basically it asks for the parent. So you don't need to know that there is going to be an insertion order, because every time when you do insertion, okay, it's basically okay, insert at any position. But level order traversal, insert level order. Yeah, these always use the void paradigm, and wherever I've seen that people use this void paradigm most of the time, still don't know exactly why. Okay, let me just create it some root reference, then the data, then the parent data, then of course the, what do you call this, direction. So I'm thinking that it should be a double pointer. Let me just write down what I'm thinking, otherwise sorry, this delay because I am doing it in a like study with me kind of an order, because some a senior actually saw that video and he said that you are doing it like a study with me type. So I really liked it, like that concept, because I remember in my JE times I used to have this kind of channel. Forgot that channel, if that channel is now existing. I remember that guy used to post this video where he used to study, like, and basically live stream during his study, and it was a good channel. So let's do something like that. So you will find me doing it slowly because I am also learning in this process. So that's there. Now, uh, so basically I want this to be double pointers. So mm, this is what? This is a root pointer. This is basically this root reference pointer. What is this? Pointer, root pointer. So basically, अगर एक बार start है, so this is the root of the tree. So pointer to the root of the tree, and I am just referencing it because if the root changes, then this reference should change, right? So I am passing it passed by reference just to update the root changes. I think that should make sense. Basically, when I have double pointer means what? I'm dereferencing it in my head to the pointer pointing to the address of the root of the tree. Yeah, so it makes sense. Yeah, should be fine. Should be fine. Now, I don't know if you okay, if anyone is actually watching these videos, and if you have doubt, I have doubts like how am I doing it correctly or not, because unless and until I run the program and check check out how everything is working, because it is Cena, so I'm modularizing it a whole lot basically. After I compile it, na, it's going to have so many errors. Like it's going to be terrible, terrible. So void display tree. That should be the very simple naming convention. And so that just bt node root. Wow, rot. Maybe I should name it rot. Next, from name number 3 is basically, yeah, in order in order non-recursive CURSIVE. Of course, I'm going to be passing it bt node root. Let's yank this line, paste it here. If I remember, yeah, it should be 0. And now this is not in order, but post order. I don't need this extra lines. So 0, 5. Now post order is done. Basically next is what? Maximum value. So it was something like find max, right? Yeah, it was find max. Let me just zoom in a bit. So in find max, void, no, it was int. So it will return the maximum value. So that's why it's int. Find max. And the same thing goes. Zero 6. Next is in is exists. So wait, I made that is exists inside the utils. Let me just check it once. Should be in utils.h. No, I did not. That was basically for the stats. So is exists, and I'm again thinking that I should do it a bull, because it's going to be a simple 0 and 1 case. But the question asks to do int. 1 if it is present, else returns 0. It should be a bull. But this question is asking me to do it as int. Okay. Ideally, if it were me, I would be using bull. But because the question is asking me to use int, so let's just go with int. It won't make much of difference. I don't know how much bull actually takes. Let me just search it once. How much a bull, what is variable takes memory in C. Oh, okay. Wait. Oh, nice. Ideally, basically what happens, it should take 1 bit, because you just need to store a true and like true and false value. But damn, C is inefficient here. C is really inefficient because of the computing restrictions, not the structure. So I think the Stack Overflow should have a better way of saying. Hmm. So yeah, user declares is large enough to store 0 and 1. So smaller than 1, but it would be legal for it to store larger. Okay. Yeah, so basically it's taking 1 byte of data, that's 8 bits, which it doesn't need. Wait. If that is the case, that means this kind of 7 bits are filled with some garbage value or something like that, right? If that is if that is the case, let me just oh, what happened? Okay, so if I just name something like random test dot c and just go, okay, this is we are digressing a bit. Okay, include, let's do stdio.h, include stdbol.h. I want to check it out. So main now, it should be something like int, let's do a, let's do bull b, print f, or maybe r equals to, why is it in visual select mode? So the size of, let's just do an int, is, I think percentage d would be okay. Size of returns an integer if I remember. Oh man, why do I forget that this NVIM has this issue of undoing everything that you do in the last program. The size of int is %d. Now, basically, I need to use the size of operator for a, and if I just yank it, paste it, and I'm just changing this to bool, insert b, done. Let's just do GCC random o random test c. Okay. Oh, because yeah, makes sense. Or I can just not use this flag, or not flag. What do you call this? Macro. Do I have 2 ints? Oh man, what the heck is this? Okay, fine. Now let's do random test. It is showing 1. I know the size of int is 4 bytes. So can we, my question is, can we access those sizes? If I just go to here, if I just go here and do something like increment, now what's going to happen? It's still there. Bit weird. How is it working? So if I have something like b equals 10, basically I'm assigning the value of 10 to it, I'm facing no errors, and it is still size is 0. No, zero. Sorry, by the size is one. Oh, why? I'm just printing the size. I should also be printing the value. Otherwise, there's no way I can understand. Nah. So, and value is uh, B step one. So B, yeah. So it is following the logic. Anything greater than, okay, it is, and because it is having some memory, some unused memory in those 7 bits. Can I access those memory? Somehow I can I like put something there. Well, I'm going to do it later. It's an interesting problem that I'm thinking. Okay, that was a little bit of digression, but yeah. So root, what I was doing is exist. Root. What was the question at this point? Ah, there should be another int t. Okay. D, probably problem 6 done. Not done, but uh no, not done, but basically the architecture done. Next is this is get height. Int get height. Let's go with again bt node root. Hey, if I do it something like this, will this be better? Just a question. I don't know. Next will be int it was height, probably it was, now let's make it level. Mm, see, in level order traversal, I think I do need this level as well. So because I need some level, so if you know, if you go back to the algorithm of how level order traversal works, I do need a helper function for it. So I can do, the question just say that you can only have the root and the data, but I also need the level. I'm getting a weird idea. So let's make it something like this. Okay. So this is the structure that they have given. Just go root D, but I need to have mm, and have this structure for it. So what I can do, I can just call it something like get level utils or util, and this will be my main function, and this is basically will be a wrapper function for me. So yeah, makes sense. Let's go to 09, and it was probably the zigzag. Let me just check it. Level order is not, no. Level order is 9. Am I forgetting something? Level order is 9, 7, 8. Oh, it was level order. I was thinking of the level. Okay. So we need to have this. So basically we can use the level utilities later in my code to get to the level, and in that level I do need to go here left and right. So ah, just have the normal level numbers. Okay, I might change this. Might change the logic later. Let's go with level order, and level order is basically I have BT node, root, and you're done. Which I need the problems. P P P P P P P P. Listen. So after this, we need void zigzag. Zigzag. The name is kind of like, I don't know if I ever made a function with this name zigzag, but yeah, let's make it. Like not make it. Currently, we are just naming it. We are still we are still long way to even making it. Get leaf count. I remember it was leaf count, then it was full like not leaf but full nodes, number of full nodes, and then it was number of half nodes. Yeah. Okay. So getting the leaf count, probably again include the same structure. Int get full node count, pt node root, one three. Next we need to get the half node count, pt node root. So oh, where am I in this insertion in replace mode? Whatever. So after half node, what do we have? Check if the two trees are identical. So is identical and then is mirror. Okay, what is the return type? Level order, full node, in. Okay. It again should be boolean. Okay, I just want to know if there is a security issue with this boolean. Really want to know, but maybe I shall do a little check on it. So number 14 is basically in is identical, but then I need two trees, so it should be something like bt node root 1 and bt node root 2. So once we are done with that, we need to make in is mirror. Again, bt node, same structure. Let's do the root 1 and root 2. So can I do something like bt node? Then that's what's probably we have we of this thing now. Within when you just press random buttons, probably I'm just feeling too sleepy at this point. I just want to complete one program, and I'm just doing this labor intensive coding. Basically, it is not exactly labor intensive, whatever. Check if the trees are in a silver. Okay, print ancestors, and get the breadth. Okay, and then we'll complete. Okay, so int or void. Let me just use bull at this point. Should I use bull? Let's just use print ancestors bt node root. So I also need the data d, and next I need to do the width or breadth. Int get vth root. Next, finally, problem number 18. We need to make the complete tree from the user input. So it will be basically bt node build complete tree input. Do I need any? Nah, because it is going to build it from scratch. If I need, I'm going to add to it later. It's going to save. So I just wrote about 79 lines and about 1 kilobyte of data written. Okay. Now here it is done. Here it is done. So we are finally done with just prototyping all the functions. Just think that we were just doing the prototyping of all the functions. Now we need to create all of those functions. Oh man, I don't know how many lines of C code will it be. Probably 500 lines minimum. Let's do it. Let's do it, because at the end of the day, that's the fun of C, right? So let's just keep the prototypes here. And on this window, if we just go back to nvim binary tree dot C, and it is totally, which is kind of expected. So I do a zoom in. I'm thinking of using the AI at this point, but if I use it, then what's the point of like this recording of me doing it? Whatever. Basically, I just want to. Why am I doing it again? And why is it that at late night I have these thoughts? What the heck am I doing with my life? Ah, like really, why am I making all this? I could have just mm, be. It was util shortage, or I should be having it in quotes, right? I'm also trying to learn a little bit of NVIM, because I know the key bindings but haven't explicitly used it. I need to improve this Vim NVIM key bindings, and I need to do the LSP. And why the heck am I even currently continuously speaking? I need a man. basically for some functions, basically for max function, I needed the max function. Now I can actually make a simple max function as well. Oh, what just happened? If I do undo, again undo. नहीं भाई कुछ ज़्यादा होगा control redo. Okay, okay. I'm not going to write it again. So let's create a max function of our own. It's just going to take in A, in B, and it's going to return. Let's use ternary for it. If A is greater than B, then first is true, then is false. Then if it is true, return A. If it is false, return B, and we are done. Nice. Now let's go. First, on. I need to get myself some water before I begin. Yeah, got myself some water. Let's begin again. I do think I should be having it just so that I can have a better view. Now, oh, I am zooming it just so that the uh, I don't know why am I zooming it. I need a reason for everything at this point. Okay, BT node. Probably have it like this. This is why I don't like it. If I just go back here and if I just yank this line, then go back here, paste, okay, paste this, it's working. Should I have it in full screen? Should I have it in full screen? Looks good. Okay. I don't know why am I having this kind of thoughts that is this good or not. So I had this reference. Okay. So from there I need to work myself into making the whole insertion. First I need to have the create node. Wait, did I make the create? I think I remember I making the create node. So we just have one more terminal somewhere here that will help me to check out uh, in utils.c. Yes, I do have the create node, and this is basically for the bt node. Yeah, it's for the tree, so it's going to return it. So this one is already there, so I don't need to worry about anything else. So I can just have bt node, just have a new node which I'm going to create node data. Done. Now basically if that node is properly not created, maybe some null or whatever it is, then so the printf, or should I do p-error? Let's do p-error. Okay, what is the reason and difference between when should we use p-error versus f printf or pair printing. Yeah. Will give you the interpreted value of error number, which is a thread local error value written by the POSIX. POSIX is there. For instance, if you made a call to open and there is an error generated and it returns -1, you could call p error immediately afterwards. See the actual error was. Keep in mind, if you call other system calls in the meantime, then the value in the p error will be written over. Calling p error won't be of any use in diagnosing your issue if the error was generated by an so if you have multiple errors and one gets overwritten by other, so it basically makes no sense to have so many p errors, right? Okay, makes sense. Now, on the other hand, you can print your own custom error message. By printing to standard error, you avoid your error and so similar to peer now standard error. Okay, yeah. Currently, the situation is such that I might have multiple errors, one after another because of failure. So it's better I don't use p error. I think I can use a printf with the standard error and just have it something like fail to create a new one. I think this makes more sense, and you just return. I haven't such a by the way. Can I? Okay, first let me return. It should be root reference, but I have to be very careful because the return type here is a pointer to that, and I'm having the root reference as double star, so that's a pointer to a pointer. Think it should be. Think it should be pointer because then I'm returning the root itself. So yeah, then I'm returning the root itself. Okay. Now, there might be two cases while we are inserting manually. One case would be when there is nothing, so you are inserting the root node itself. That would be our case one. So I can write it as case one when when it is the beginning of it, when it is the beginning of the universe. Oh, I don't need. Okay, so if what was it I did? No, root rep data, parent data. What was what was I going to even do? I'm feeling too much sleepy at this point. So if I just go back, oh man, note that you need to take the following as input number. So I have the parent data. Hmm. How to do it? If the user suppose gives no parent, then what's going to happen? I'm just thinking. Uh, I can do one thing. I can have the parent data as suppose -1, just like we have in stack, and then I can check for the root. And of course, if the root is null, then it doesn't mean anything. But suppose if the root exists, then that means parent data must not be equal to -1. Yeah, I think that logic should work. So this is what I'm going to do. Probably in the main code, I need to remember that I'm going to introduce the parent data as -1 as a backend value so that the insertion happened correctly or not can be checked. So if the parent data is equal to -1, and that's the case, then if मतलब parent तो सही से नहीं है भाई, ये तो पता चल गया. And if the root ref, wait, am I using root anywhere here? Yeah, if the root reference is not equal to null, then there is this issue that basically what happens then, the root already exists and you are inserting at the root, because -1 basically means it is the initial value and the user can't enter any value, so it has to be there. And yeah, I think my logic makes sense. So fprintf, let's do root already exists, and if it exists, then we can't do anything basically. So what can I do? I can just free the node because we just created it, but there was no use for it. So new, this needs to be, and then I just return the root ref. Now here comes the normal thing where, wait, should it be here? No, because root hai na, so of course it will be -1. So then root ref equals to the new node, and I can just have a printf statement saying node %d is inserted as root, and it is data basically, right? Yeah, data. So now we handle when it is at the beginning of the universe, basically there exists nothing. So whatever you're inserting is at the root. So thus, I think the logic sounds sound enough. Now let's do the case 2, which should be a way easier one. Like easier one in the thinking, like not really easy, but don't know what to say. Let's see. Inserting as non-root. Now we are going to be inserting as non-root. So if to root ref equal to null, then of course we are going to be having some issues. So let's do printf standard error. What does it even mean? Basically, it means that if it is null, then basically means there is nothing in the tree, and it needs to be inserted as the wait. I'm just thinking. If their root ref means, then it is beginning, right? So then he should be entering it as some parent. Wait, the logic doesn't make sense. Doesn't make sense. Uh, the parent data. So okay. It might happen. So I'm just thinking. I'm just following the normal syntax, like when we do as a null and everything. But if you just go by that kind of logic, what happens that you are inserting some kind of parent, say 10, to a tree where the tree doesn't exist. Basically, it doesn't exist means no one created the tree. But if you know that no one created the tree, then of course you are going to have the parent data as -1, as was mentioned like earlier. Like I'm going to mention it later in the code, or I'm going to hard code it. Let's see what I do. But if that is the case, then it is like you know that it does. So yeah, I don't know if I am able to make it understandable. Currently understanding it myself as a logic. So if I'm inserting something as a non-root, means I know that the tree exists and there should exist a parent value. But suppose the tree is not existing and I'm inserting a parent value which doesn't exist. So basically means the tree is empty. So I just print tree is, like this is a beauty of this kind of structure, I feel like, because I forgot everything. Let's say I don't know much of the logic that I'm going to do, but if I just follow that, if you first check the null and then you do it, because I always follow this logic, I tend to find these cases more what do you call this, regularly, where this kind of events might happen, where you think the tree exists, you enter a parent, but the tree doesn't exist. So first you need to do this checking, and then without even that parent data. So these cases are very, very crucial, I do think. So basically you then do free new node, and then you just return the null. And yeah, that makes sense. Basically now we need to do all of the next part, which is basically we need to find the node. So I think I should make the find node program first. So remember, I think I haven't made the utils.c yet. Yeah, no, haven't made the utils.c. What is it that I'm doing? Oh, let me just save it. Utils.c. How much have I made? I might create. Yeah, I have made the find node function. So find node, I have the find node function, right? Okay. So I have the find node function. So I can use the find node here as well. So I can just use that to first find a parent, and then okay, let me see how the find node works. I forgot. I made it this evening and I forgot. Wow. So yeah, it returns. It returns. So I just do bt node say this is my parent node. Do I have, no, I don't. So parent node that is going to be returned by this find function. So find node, so root ref, and I need to send the parent data. Okay, good. Now don't tell me I just need to write this again. Parent node equal to null. Then basically we do again and printf standard error backslash n. Parent doesn't exist or not found. It can be any of them. Parent doesn't exist or not found. And we just do the pre new node, parent node. Hmm. Hmm. I'm thinking. Should it be because new node needs to be freed, but parent node, if nothing happens, it's going to return null, right? So no. Yeah. Yeah. It's going to return null. So if it is returning null, it is returning null to this pointer. So we can just return null. I just want to have this testing later. Going to write it here. Remember, so basically in Valgrind, what happens is that there is possibly reachable thing. This place might give that possibly reachable memory bytes or memory, what do you call it? Memory bytes, memory locations, memory blocks, yeah, memory blocks. And I want to test it if the following line makes any difference. And the following line is basically free parent node. That's it. That's something I want to check, but yeah, so I shall check it. I just want to check it, so let it be there. Now, after this, we need to think about what we are going to do. Suppose the parent node, that means, is found. Then now I need to think about the direction and whether that direction is free or not. So if the direction, okay, I just don't want to go through that, checking if the user has given L and R, or instead he has written his own name that go to the direction of my name or something like that. I just don't want to. I probably will handle it later in the while asking for that. So yeah, there are users who might give it. I'm just going to have with some privilege of thinking that the user is a little bit sane. We just should not be thinking that the user is sane, but user is never the sane person. Sane means, you know what I mean. Now, if the action is on the left and the left is not occupied. So basically, parent node के आगे जाएगा child. So parent node left is equal to null. Then only we can add it, right? So if it is equal to null, then only we can do parent node left with a new node, and I can just do a printf on successful insertion that node doesn't b is inserted successfully as the left child of percent d. Now I need data, parent data. Make sense? Yeah, it makes sense to me at least. Else, I think it should be else if, then I need to do the conditional. So direction is equal to right capital R, or direct small r, as if that is the case, then if parent node what? That is not coming. Again, this is endgame, so probably that's an endgame issue. I'm going to have too many nested if statements here. So, parent node. I'm slowing down a lot at this point. And just have a printf node e is inserted successfully as my child of person B. Data and what? Done. Now I need to think about this. If statement is done, what happens if, okay, these are not there. So basically, I need to write one else statement. Are you stupid? Use L or R or left and right. And I'm just going to free the new node. Done. Next, this is done. This is done. This is direction. Wait. Did I mess it up somewhere? Let me just think. first left or right. Okay, then if it is left, then okay, good. If का अगर नहीं हुआ, if का अगर यहाँ पे नहीं हुआ, then you go to the mm, I think there should be one more if. So basically what happens if left and right, then here, yeah, yeah, I think I missed something here. So left and right, parent left, parent node ka left. I think I can write an else statement here. And in that else statement, we can just do a printf standard error that basically left child already exists. Child exists. And if that is the case, I can just free the node. This is the else statement. And I think I should complete the if direction here itself. If will be completed here. Now then else if should be here. Yes, else if then direction is like this. If right child is now there, then I do an else for not this, for this if. So I need to do an else for this if, and that will be a April F. Right child already exists. And let's do a free new node. Now then else is done. else if का if हो गया, फिर if का जो है else पाथ आएगा जहां पे yeah, basically this thing will be going, and then this, yeah, yes. Probably I need to check. This is the, so if I just click on this, it should be the beginning of this function or somewhere else. Oh, let me just save it at this point. Save it and let me just open it on this VS Codium, VS Code, just so that I can see it properly. I am making it in binary tree.c. Just don't need the utils right now. This is a huge function. So this ends here. Okay. Okay, the brackets and parentheses are okay. So this here, this is this, this is this, and this is for the if block. This is for the else if. What just happened? So there's a right child. Okay, it was trying to make it again. No, I have this, I have this. Okay. Let's just do return the root ref. Okay, thank you for this. So basically, you don't need to free the parent node because this is not as the parent node is not dynamically allotted. Okay. Oh, that makes sense actually. So that's why if I okay. So when only dynamical allocation happens, that memory leaking chance will be way more. But what is happening? No, I remember I'm using the find node, right? If I just go to my code here, find node, no, it is not allocating. This is searching for it. So that makes so much sense. Thank you. Sometimes this AI really helps in understanding. Okay. Let me just use here just for the sake of it. And I haven't even started typing and it is suggesting me to just do it like this. Huh. You know, good thing, but I'm going to make my own display function based on, okay, because I've already read it, it's a good idea of using the spaces like this. But even uh, our professor also did something similar to this. But I want to like make a more intuitive display function on my own. So yeah, that's there. Let me do it. Let me do it. So I'm not going to use this. Uh, Wait, why am I opening the utils.h? Okay. I think I can do one thing. I can have a helper function for this because that might make my life a lot easier. So if I just go back, nvim binary h, I can just go here, void display tree helper, and this is basically going to have some form of indentation helping. So BT node root, and let's just have it some indent here. Now because that is done, let's just go to .c wala file and what's that noise? Oh, just lizard. It was a weird scratching noise. So void I think let's make the helper function. Basically I want to have this indentation helper. So should I make the helper function right now or should I just have the tree? So I want the display tree function to just get the value and the root node. So let me just make the display tree display tree. It's simple bt node root. I just want to have printf. I think I can just do it like this. Tree display let's just do that normal formatting root. Uh, Wait, is it will not equal to null? Then it will give an error. No, not equal to null means there is something. So uh, if it is equal to null means the an empty tree. Okay, I'm feeling pretty sleepy at this point. Printf because it is void, right? I can just use return. And I can just call display tree helper. And from root, the indentation should be 0. And I can just have it some like this. So now I need to make this void display tree helper. And basically I need to have the indentation as well. I need to dynamically change the indentation. First, let's just have the BT node. Let's call it indent. Is indent? Yeah, the color is fine. If root is null, then of course there is nothing. So let's just do a return. Now display helper function. I'm going to do it like this. Then I'm going to go. So let me just think about it. Root, should I go left first? No. In the terminal, it's something like always up to down, like top to down. So then if I have the tree totally 90-degree rotated, so the right subtree should come first, then so right indent, let's just increase it by 4. Next, I just do the printing for I 0. Hey, I don't know why this int I equal to 0 sometimes say it doesn't work. Let's see if it gives an error. No, I don't know. It gives error sometimes. I remember in Java programming I used to have this issue where, was it Java or C? Where if you just introduce the variable or initialize the variable inside the for loop, it used to give some kind of error. Was it Java or C? I can't remember. Okay, print there. So you don't need the backslash n, the space for indentation. So should I give one space or two? One, let's just go with everyone, like increment of one means one space. So that's just it. And go printf. Let's print the data. So let's just percentage d. And a new line. Do I need a new line? Let me just think about it. Print डेटा निकला, नया लाइन में गया, उसके बाद स्पेस. हाँ, सो ठीक है. रूट data is done. Now because we have done the right subtree, now this is time for the left subtree. So root left, root left indent. Let's just increase it to 4. And then, so the helper functions are done. Now we need to do a lot more coding. So and then We still need to make the in order non-recursive, post order non-recursive. So probably I'm going to make the non-recursive functions for now, and after that probably I'm going to go back to sleep because I'm just feeling tired at this point. Void in order non. Did I? No, I gave it correctly. So like there is no space. Recursive. See what I hope there is no spelling errors. See what? Okay, yeah, makes sense. EP node. So because okay, of course, first let me, without saying anything, do the initial root checkup. It is void, right? So return. Now, uh, so here is where I shall be requiring a stack. So I remember I have created a stack, like the basic stack structure, and I can create a stack pointer using the create stack function. So now I have the stack ready, but if suppose there is some issue with creating the stack, so we just have that as well. Let me just return. Now we are going to do this in order non-recursive, right? So in order traversal non-recursive. Should have do it. I have the stack. Uh, my brain is not working. In order traversal. Do you have a GIF for it? Hmm. Basically, it means what? Left data, right. That is thing, LDR. So, first, let's have the copy of the root because, of course, we are not going to move the root. So, current root. So, I'm going to have this current as the root, like basically a copy of the root. Now, let me do a simple thing first. In order non-recursive. Now, so how do we move it? So first I need to go to the leftmost, then I need to print out the data, then I have to go to the rightmost. And that's a very simple logic. So while I just have this parent not equal to null, so I can just simply push the values s comma current, and I just update the current. So first I have to go to the left path. So hmm, hmm. I think it is fine. Will it? I just need to check the definition of previous box. C once. Where is that QTQ? Where is the push operation? Yeah. Hmm. Yeah, I'm able to store this node. I'm passing the pointer. So basically, I have this pointer current. I'm passing the pointer. Okay, why is it that I'm confusing one thing? Uh, when you write it like this, that without the star, I initialized it as the star. So current is this pointer. So it should be going as a pointer. If I don't get it right now, then like I don't get it right, means correct right now, then when it's going to compile now, it's going to give me so many errors. Give me some time. Let me just think about it. So I can't say anything in this point. I'm just thinking. I think, yeah, it's fine. But I can have one more condition, which is basically is stack empty. Just so like I'm giving it in OR so that yeah, it's fine, it's fine. Hmm. So what is happening? It is going to the leftmost part of the subtree and getting all the data values. Now I need to pop it out, and while popping, yeah. So I need to pop out the stack, but wait, if I just think about it, it has gone to the leftmost. So while it is not equal to null, means at the last stage, it has become null because it has gone to the leftmost subtree and the leftmost leaf. It's now currently on the null of that leaf. So current must be at the null of the leftmost leaf. Now, how should I go? Wait, if it is at the left most of the leaf, while current is not equal to none, the last point it happened is that it changed to the last leaf node, which is not null, took took it, and yeah, so now I need to start printing the values from the top. From the top. Yeah, from the top itself. So I can just have current pop equal to pop S. Then if basically current is fine, so current unless until it is equal to 0. So I am hoping that there are the tree is made of non-negative, non-negative, not only positive, or not only, yeah, 0 is also positive. So what do you call this? Strictly greater than 0 positive integers. So current is fine. So I need to print the data. And just use tab. Data. This is done. Wait. Hmm. Mm, no, doesn't make sense. It doesn't make sense. I think I should have uh why is it that my brain is literally not working? While current is, yeah, this is fine. This whole thing needs to be under a single loop. Otherwise, I won't be doing it. But can I do it something like this? Okay. Okay, is it some okay? This is a question I have. If you have a same loop like 1 to n and then again 1 to n, then you print inside the basically you're just repeating the same check condition, and checking is okay. What operation in computer here I'm performing, which is less intensive? I think traversal is more expensive than checking. Which is more expensive? Can this Google without any chat or AI answer this? So, which is more expensive, traversal or checking? No. So I'm going to think. Let me think. Checking is basically you take those two values and check, and traversal you need to change from one page or in the heap. It might be something like to another data. You need to find it. Checking means you already have those two, and you're just doing a boolean check, like value check. So if that is the case, then I can have another, what do you call this, checker current, which is exactly the same. What am I doing? Not equal to null. Oh, not equal to, so if I have the exact same thing again, and I just push these two, so hmm, I'm still inside the while, right? Then I can actually, in the if current, that means that is true till we encounter a null. So currently, because of this pop operation earlier, now it is not a null. I can just do current, mm, current, mm, right, and yeah. Hmm. This should be all right. After this, I just need a backslash n. And do I need to free anything? Yeah, of course I need to free the stack. Okay, free the stack. I have made that free. What just happened? Stack. Done. Okay, the logic seems sound. By the way, I think I should be marking it as problem 1 and problem 2. Problem 01 and this should be problem 02. Problem 03. And it took me, what, 3 hours? Really? How many hours has it been? Okay, 2 hours to solve just 3 damn problems. It took me 3 hours to solve no, 2 hours to solve 3 problems. I should be ashamed at this point. What am I doing? So, what just happened? I don't know. No, nothing happened. Let me do a undo. I say undo. Yeah. So this was the state. Fine. Now we need to do problem 04. This one would be a bit easy, I think. Let's go to visual mode. Okay. yank these lines, paste this, because we are going to make just simple changes. So it's pre-order or post-order? Huh. Say no. Post-order, yeah. Post. Okay, I forgot it was capital. Which one did I give? Ah, small. So post-order. Wait, yeah, the name is fine. So for post-order, wait, for post-order I can't do. Oh, if I think about it, post order means, what does post order mean? Post order basically means, I can just write it here. This L R D, left, right, and then data. Hmm, so if it is something like that, then what should I do? Please go to here and see the diagram a bit. I'm again telling that I'm just thinking. I am just thinking. I don't know. And just push the root stack. You know what? Left, right, data. I'm, I think what I am thinking is not the most efficient way of doing it, but basically you can have two different stacks for left and right and then just print it out. Hmm, I think what I'm thinking is not probably the most efficient. You can probably do it with a single stack. But how do you go back? And these trees are not like that, you can go back. Hmm. I think I'm going to increase the memory complexity a bit. So correct me later if I'm wrong, which most of the chances are that I'm wrong. Uh, if I do something like this, and of course like a checker. So if mm, means some kind of fail something has failed. So if something has failed, if is S1, or even A1, but we just free stack of S1 is S2, then we basically we stack of, and then you just return. Now I don't need this one here. First, I need to wait. Do I need to make a copy of this here? I can just recursively do it, right? Not recursively, sorry. What do you call this? In the loop, I can do it instead of having it outside. So this is the logic which I think might not be good, but let's try. So here I can have push. I just push the root to the first stack because I'm going to create a node called, let's call it current. Just using the current surname there. So just don't need this part. And I'm just checking for the S1 right now. So I don't need this. You know what? B, yeah, only this whole part. Let's just delete all this and just create this anew. So I need more notation. Current to pop. Let's just pop that S1. Basically, I just have the root. Now, if I have the root and I just pushed it to the current, not push it, but copied, popped it from the current, from the stack. So that means it is currently not empty. Then I can just go and push the current to the second stack, and I can now go and do the left and right separately. So now if node left, oh, I'm seeing this node, it's current node, node keyboard out, sleepy. With the current left, basically I just can push it to the first stack. If current, right? Current, right, left, right, data, right, right. Current, right. Okay. Hmm. Now I do need to print out those elements as well. So while uh, is stack empty, and where do we have all of this? We basically have it in the second stack. So no. Okay, I know I haven't been speaking a lot right now because while coding even I'm thinking if what I'm doing is correct. So give me just a moment. I'm going to explain what I'm going to do, what I have done. So oh, I deleted that. Yes. Okay, so this is what I have done. So basically you create two stacks. Okay, S1 and S2. Then you push the root to the S first stack and you create a node. Now here from after all this, basically your logic starts from here. So here what I have done is a very simple thing. Like instead of having a single stack for like basically left and right or something, I'm going to have this two stacks so that they can carry out the work in a what do you call this? Or if not efficient, this is probably not the most efficient, but they divide the work. Okay. So first, of course, a simple checkup that if the stack is empty or not. And what happens is that basically first the root was there, right? So the root was inside this first stack. Now, as you pop out the root in the current one, the current particular node, now it has the root. So as it has the root, you can just know that it should not be empty, right? Because we already had that checking up and all this. So now it should not be empty. So it should be a true condition. So inside the true condition, we go and we just push the root inside the second step. Now we go to the left and the left value is now pushed into the first stack, and then basically we go to the right and the right value is pushed to the wait, it should be second stack. No, left and right. No. It should be thing. Should be both should be in the single stack here. So if I just go to the diagram, S1 will currently just think about it. S1, we popped out the root. Now, what does S1 have? S1 currently have the left and the right, right? So it goes to the left and the right, 34 and 73. Then it again goes, is the S1 empty? No, it is not empty. So it's false. Is empty. So empty is false. Yeah. Wait, wait. Did I make something wrong? Oh, yeah, that was going to be a blunder right now. Yeah. Or I could have just is full. No, it's full so that we use. Yeah, so did I do something, some mistake here? Uh, display in order. Yeah. Is stack empty? Is stack empty? Yeah, I did this mistake here. Is stack empty? So yeah, that's a mistake. I just don't know how many more mistakes I might have done. And these are very, what do you call this, crucial and logical mistakes. Basically, these are typos. I'm thinking something but might not be doing it. Uh, okay, so let's go. So after all this, the left and right is there. Then what happens is that you just you have the current value incremented and all this, but basically the loop hasn't ended, right? So we go back. Where is it? It's starting here. So we go back and basically you pop out the last element from the S1 stack, which could be what? It was the right? So you take the right and put it in the current. So now current has this 73 value. Then you push the current into S2. Means in the second stack, it's currently having the right value, means it was previously having the root. Now it has the 73. So 49 and 73. Now you do the current left and you push it to the S1. So if you do it like this, then you have the 60 and the 79. And then again the loop goes. Then you push what? The 79. 79, right? Yeah. 79 into the current. And basically, if current is, of course, it is not null. So you go to the left and right, those two are nulls, basically. And you are done this part. Okay, you have done this part. Then you just see that you push the, yeah, it's done. Then you just go back. Is the stack empty? No, it is still not. So now the issue is that because both of them are now null. Wait, is my logic correct? Hmm. Yeah. Then okay, I don't know if this stream will might go long. Let me just pause the recording a bit to think about it at this point. I need some pen and paper to just write it, scratch it, and check it. So yeah, I was actually doing a very stupid mistake that uh, why is it not working? Basically, I was just kind of confused with it. So what happens is that after you have it null, then you just continue with it, right? And as you continue, what happens? Basically, you pop out this value, right? 34. Like after you just pop out this, and this, and then you just go on with 34 as this, where is it, current statement, this S1. So as you go to 34, then you just repeat the process again and you get back to it. Means like suppose you have you can just go like this. So let's do it. Where is it? Root S1 में root है. So I should have this kind of like, should I have it something like this? Maybe. So I can just have, let's do it like this so that we so that I can just explain it. I know the video is going too long. Let's see. So S1 may be care. S1 will have, so there are three things: S1, current, and S2. So first you just push the root into the S1, means you have 49. So after that you just pop the root and put it into the current. So basically you now have 49 here and you don't have 49 here. So that's there. Next, you push the current into S2. Means I think like I did this current. Yeah, you push the current to the S2. So here, because I'm pushing it, I'm not destroying it. So it will have 49 here. Then current to left, current left and then right, 34 and 73 goes to S1. So basically it goes 34 and 73. Done. After that, we are just checking S1. Is it empty? No, it's not. Is it empty? Is false, which means it's true. That is not. Voila. So then you just pop out the S1 last item, that is 73, and give it to current. So 73 is now popped out and given to current. So it is now 73. Now यहाँ पे तो हो गया 73, उसके बाद लिख लो कहाँ पे गया, sorry, S1 pop out 73, then current, yeah, then I need to push the current, which is 73, into S2. Did I do some mistake? Insert, so to delete it. Okay, 73 needs to be here. It's the 34 references there, right here. Now current left and right. So 73 is left and right, that's 60 and 79. Needs to be there. 60 and 79. After that, because it is not empty, then you just pop out the last item from S1 and you just put it into the current, which is 79, and basically you change it from 73 to 79. Then you push the current into S2. Basically you push it here, 79, and then you push the currents left and right, which is basically null. So here, and you know, like basically you can't push that null character here, so nothing gets pushed, and you just go back and just check. Okay, is the stack empty? And the answer is no, so the opposite value is true. Then you just pop out the S1, which is 60. So S1 gets popped out to 60 here. Then you just do push the value of current to S2 here, which is 60. And then what happens? You just try to basically go to the left and right of 60, which is here for left, it is basically 55. Push it to S1, then what happens? Other is not, nothing is there, so, and it is not empty. So you basically just go again and pop out the last item from S1 into current. So that is 55 into current. Now you have to basically go to left and right of 55, which is basically nothing. So you again go back, you pop the S1 item, that is 34. Am I missing something? Wait. Undo. Current was 55. 55 left and right. Push the current value to S2. I think I forgot that part. Basically, 55 will be here. Then, yeah, then there is nothing on left and right. So that makes sense. Now you go back and S1 will basically have 34. So you push it here, 34. Then you go to the left and no, 34 is pushed from like pop to current. So yeah, then you push the current value, that is 34, to S2. So it is 34. Then you go to the left and right and push it to S1. So 12 and 40, 12 and 40. And then basically you just do it again. Means you again check if it is empty, it is not empty. So then you take the 40, then you just pop it out, put it into current. Then from that, you just put the current value right here at 40. And basically you just go to the left and right of 40. For here, it is just the left. So you will just go to 38. And this is how it just goes on. So you can understand what we are getting. This is left, right data. So basically you go to the extreme left, then you go to the extreme right, and you just print out the data. And yeah, basically this should be how we're going to be having it. But it needs to be printed out. Yeah. So we have printed out the S2 stack, where we are going to have this order, post order non-recursive. Now this was just the problem 4, and if I just go to in binary 3 dot c, not c, dot h, then as you can see we have completed till post order. We still need to do the find max, and okay, we need to do is exist, we need to do height, level. I think let's do till problem number 5. Okay, so I think I can do it. Let's just see. Problem 05, which is basically what? Find the maximum, right? So int find max pt node is to the root, and if root is equal to null, if root is equal to null, then you just do a return. I can put it at anything. Okay, so I can put it at -1. There was this tag, if I remember, int main or something. Int c. Yeah, there it is. Macron say that's the minimum. So it is defined in the limits.h. Oh, okay. Okay. I can use it. So let's go back to the beginning and have include limits. Is it limits.h? Like yeah, limits.h. So I can just have int min. Now the thing is, I need to return the result. So result, I can just start with the roots data. This is basically the normal finding maximum algorithm. So there will be a left data, there will be a right data. So in left res equals to, I can just do find max again and just pass the root left. I can just have the same thing, right res find max root right. Done. Now basically after you go to the like, if I just go and go and go and go and go and I just go it like that. So at the outside go at the end of the stack. So here I can do if the left result is greater than the result, then I can just have the result equal to the left result. And of course, this is going to be the same for here. Right result, 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 right. And just return the result. Done. It was at least a simple one. I think the is exist is also simple, so we can do it. Problem 06 in is exists, and the structure is bt node star root is recording everything. Yeah, we node star root int d, and let's start it. So if basically the same thing we are just going to repeat root. Okay, basically that means what? It's nothing. So return 0. Now if you find it, then it's good. So if root data equal to whatever it was, the, then I just do return 1, and you know what's going to happen. uh, I can do the left one, then I do the right one, and I'm thinking of doing it in a single line to basically return is exist, and I just pass root left comma d, or is exist root right, and we are done. Now we are done with the is exist. Next is get height. This is a very simple recursive call. Basically, you just see that, okay, on the left side, does this say data exists? On the right, if it exists, then it suddenly just returns one and it's gone and it's done. If it doesn't, then it just goes to the right side and just goes and check. And if it is there, good. If it's not, returns none. So this is a very simple one. I think the next one is height one. So before level order, I think we can do everything before the level order, because level order or the getting the level, that part will be a little bit difficult, or what do you call this, currently cumbersome to think about. So problem 06 के बाद लेते हैं 07, and I am still left with, even if I solve till, let's say, still I'm like, where I have so many problems to solve here. Okay, int get, क्या नाम दिया था, height, we note, so root if, of course the same thing is going to repeat again. Do I need, I think it just can return -1. Else int, क्या बोलूं, I need to get the height. There should be something like the left height, which you basically just, so I can just use a recursive call to do this. Right. So after this, basically now we can use the max function that I created just at the beginning. Just get whichever is the maximum out of these two, or you can just use the max function of, remember the mat.h का max function है, max function in mat.h. Yeah, it is fmax. Fmax is, I think, does something a max function, or, oh, floating point. Okay, so I can just use my own max function. I was thinking, like, there was this issue with, somewhere I did, like, I remember it was a story, basically not a story, but what happened in class 11 is that I remember I had to make a function such that it will compare between two integers and floats and give out the maximum of them. So the comparison between two different data types sometimes can't be done. There are issues with Windows Turbo C. So basically you need to create your own max function for it. That time we were very new, so creating a function was a huge deal for us. Okay, even if it was a simple max function. And suddenly I remember Mriganko was there. He showed me that there exists this max function inside uh math.h, and I was like, okay, if it has max function, then good. When I can't remember, he showed me that it was not exactly the max function, so I just now searched it up, and it kind of just refreshed my memory of my school days. So yeah, so just return what? So after this is done, else path. Uh, yeah, I can just do a comparison here only. So, um, and those were good old days when, what can I say? Just mm, when lives were simpler. So, height basically does it from, hmm, it should go from 0, right? Yeah, it is going from 0. So, we need to add 1. Mm, it goes to the root, then it suddenly goes to null. Until then, it just increments, and yeah, it starts from 0. So, of course. So, that's your get height function. With that, we have just now written about 260 lines of code here. About not that much. You can just condense it to something like probably 50 lines because I've given a lot of spaces. But yeah, let's just do a get at dot get commit added some more problem solutions from set 1. So basically we had 401 insertions and 1 deletion. Did I delete something? Probably. Hmm. So get, I'm just going to push it to my notes there on my GitHub. So you can just have it there. With that, I think we are finally at the end of this part of the stream. Almost 3 hours, and it was, it's 4 a.m. in the morning. What am I doing? No idea. Just no idea. But yeah, if anyone is watching, or if anyone ever watches this video and actually stays till the end, thank you. But the probability of that happening is almost 0. So I don't know. Goodbye. See you.